Hi, my name is Vinay, and in the series of balance bot experiments we will see the next controller model in which we have added a force actuator in the 3D model of the balance bot. So here we have our 3D model of the balance bot, okay, which is being generated using 3D mechanics editor of medicine. So the rest of the model remains the same. That means it produces an angle which is being given to the controller model, which is this one. So here, after the gain and offset adjustment, the noises from the accelerometers are removed and given as a measured value to the PID controller, which in turn controls the position of the DC motors of the left and right and make sure that the robot or the bot remains balanced. In the 3D model, we have added a force input and we have given a 2 pulse inputs as a disturbance to the model so that we can see the control balance of the bot. So here we just simulate this model. So here we can see that some pulses coming up. So this is a filtered measured angle of it. So after a while you can see when the disturbance is being applied to the bot, so it moves up and down. So let's see the 3D model of it. So here you can see that the bot tilts up and down and tries to balance itself. So this is the animation model of the bot. Okay. So let's see the real world performance of it. So go to Tools, Real Time Toolbox, C Code Generation, and let's download using the 4C toolchain. So this is the controller we download in the real world. Always make sure that you measure the accelerometer offset before downloading this controller model. So you select the balancing bot template, go to connect block, connect the sensor input to the onboard ADC and the left and right motor to the respective channels. Click on compile and we wait for a few seconds till the compilation is done. Now let's see how the bot performs in the real world. So here we have the bot in front of us. So this will make it to run for around 10 seconds. If you want, you can even log the variables to see the performance coming up. So for example, I can ask him to log the filter output and also log the offset output. Remember, for this particular bot which I'm using right now over here, it has an accelerometer installed in the beneath the controller model board, and the offset of this bot is around 1.645. Okay, so let's run with the logging option. So I just run it. So right now the control is not that very aggressive, so that it do not oscillates too much. Bot tries to balance it, and there we can see. If you want, you can, for the start, you can just keep the bot balanced on the center position and hold it with your hand just to measure the offset. In case the offset is different, you can adjust it. So here I just opened that and the way I see it, this is the offset output. So this is good enough. This is running in the center line, so that should not be a problem. I just make the control a little bit more aggressive by increasing the gain to 5. And another. So here you can see, and I just hold the wires just to keep it center line. Yeah. So any disturbance, he just balances it back. So here you can see the performance of the filter and the offset output. So he tries to balance it very nicely. So this will be the end of the experiment. Thank you.